Welcome back to the AI Waves channel, your go-to source for all things artificial intelligence. I'm your host, Maurice, and today we're diving into the fascinating world of machine learning with part 6 of our series, How AI Works, the Basics of Machine Learning. Before we get started, make sure to hit that like button, subscribe to our channel, and leave a comment below, sharing your thoughts or experiences with machine learning. We love hearing from our community and fostering engaging discussions. In our previous videos, we explored the history and evolution of AI, from its humble beginnings to the cutting-edge innovations of today. Now, it's time to peel back the layers and understand the fundamental concepts that make AI tick. At the heart of modern AI lies machine learning, a powerful set of techniques that allow computers to learn from data and improve their performance over time. Have you ever wondered how your email filters out spam or how Netflix recommends shows you might like? Welcome to the world of machine learning. Machine learning is a crucial component of artificial intelligence, providing the nuts and bolts that allow AI to function. In layman's terms, machine learning is the process of training a computer model to make predictions or decisions based on data. But here's the catch. These decisions are not made from a set of predefined rules. Instead, machine learning algorithms learn from the data itself, like a child learning to walk, gradually improving their performance over time. The fascinating part is that these algorithms can adapt and improve as they encounter new information, much like how we humans learn from our experiences. By the end of this video, you'll have a basic understanding of machine learning and its three main types. First up is supervised learning, the process of teaching a computer model to make predictions based on labeled data. But what does this mean? Let's break it down. Imagine you're a teacher and your students are computer models. Your job is to teach these models how to identify and categorize information. The textbook you use? That's your data. But this isn't just any data, it's labeled data. Each piece of information, or data point, comes with a tag or label that identifies what it is. Now think of a real-world instance where we can use this. Let's take email spam filtering. Your email provider uses a system that's been trained to recognize what spam looks like. It's been fed thousands, if not millions, of emails, all labeled as either spam or not spam. The model studies these examples, learning what characteristics or patterns are common in spam emails. Maybe it's certain phrases like "win $1 million," or perhaps it's emails from specific domains. The model takes all this in, mapping inputs, the characteristics of the emails, to outputs, the labels of spam or not spam. Once the model has been trained on these examples, it's ready to tackle new, unseen emails. When an email arrives, the model examines it, comparing its features to what it's learned. If it matches the characteristics of spam, into the spam folder it goes. If not, it lands safely in your inbox. This is supervised learning in action. A model learning from labeled examples, making predictions for new data based on its training. It's like a student studying for a test, using past papers to understand what answers are expected, and then applying that knowledge to new questions. So in essence, supervised learning is all about examples. You show the model what to do, provide it with the right answers ahead of time, and it learns to predict outcomes based on these examples. It's like teaching a child to identify animals by showing them pictures of different animals along with their names. So that's supervised learning, teaching a model to predict outcomes based on examples. Next, let's explore unsupervised learning, where the model learns from unlabeled data. Now, this might sound a bit like trying to navigate a new city without a map, but bear with me. In unsupervised learning, the model isn't given any answers. Instead, it's like a detective trying to find patterns and structures hidden within the data. There's no right or wrong output for the model to aim at. Its job is to dig into the data and uncover any interesting relationships or groupings that might exist. Imagine you're a business owner with a vast customer base. You have heaps of data about your customers, their age, location, purchasing behavior, and so on. But you don't really know how to group these customers. You might suspect there are certain segments within your customer base, but you're not sure what they are. That's where unsupervised learning comes in. You feed all this data into a model, and it starts identifying patterns. It might find that customers from a certain age group tend to buy specific products, or that customers from a particular location have similar purchasing behavior. It's like giving the model a jigsaw puzzle and letting it figure out how the pieces fit together. So you're not telling the model, "Here are my customer segments. Learn how to classify new customers into these groups." Instead, you're saying, "Here's all my customer data. Tell me if you find any interesting groups." This is the crux of unsupervised learning. It's all about discovery and exploration. Now, this doesn't mean unsupervised learning is better or worse than supervised learning. They're just different tools for different tasks. Unsupervised learning is a powerful tool for exploratory analysis, for situations where we don't know what we're looking for, or where we want to uncover hidden patterns in our data. That's the magic of unsupervised learning. It's a bit like setting off on an adventure without a map, letting curiosity guide you to unexpected discoveries. Unsupervised learning allows models to discover hidden relationships or groupings within unlabeled data. Last but not least, let's dive into reinforcement learning, where a model learns from rewards and penalties. Picture this: you're in a maze and you're trying to find your way out. You take a step forward and you hit a dead end. You backtrack, take a different path, and voila, you're a step closer to the exit. You remember this for the next time and continue your journey. This, in essence, is the spirit of reinforcement learning. In reinforcement learning, an artificial intelligence model is like a player in a game. The model interacts with its environment, making a series of decisions or actions. For each action, the model receives feedback in the form of rewards or penalties. The objective? To learn a strategy or policy that will maximize the total reward over time. The process is iterative and dynamic. The model learns as it goes, gradually getting better at the game. Each step is a learning experience, enabling the model to refine its strategy and make more informed decisions in the future. Importantly, the model learns from its mistakes. If an action leads to a penalty, the model adjusts its strategy to avoid making the same mistake again. To illuminate this concept, let's take a look at DeepMind's AlphaGo, a shining example of reinforcement learning in action. AlphaGo is a computer program that learned to play the complex board game Go, a game with more possible board configurations than there are atoms in the universe. So, how did AlphaGo master this game? AlphaGo learned by playing millions of games against itself, exploring a vast array of strategies and outcomes. Each move was a decision, and each game was a learning opportunity. Through trial and error, AlphaGo learned to predict which moves would lead to victory and which would lead to defeat. Over time, it honed its strategy to the point where it could beat the world's top human players. Reinforcement learning is about learning the best strategy through trial and error, guided by rewards and penalties. It's a journey of continuous learning and adaptation, where the path to success is paved with both victories and mistakes. Now that we understand the basics, let's look at some real-world examples of machine learning in action. First, let's consider image recognition. This technology has been revolutionized by machine learning models, particularly those using deep learning neural networks. These models can be trained to categorize images, detect objects, and even generate completely new images. One of the most ubiquitous applications of this is facial recognition in smartphones. Machine learning algorithms analyze thousands of facial features to accurately identify users, providing a secure and convenient method for device access. Next, we'll explore the role of machine learning in natural language processing, or NLP. This is the field dedicated to enabling computers to understand, interpret, and generate human language. By training on large datasets of written or spoken language, NLP models can perform tasks like sentiment analysis, language translation, and text summarization. You've probably interacted with this technology when using voice assistants like Siri or Alexa, or even when chatting with an automated customer support system. Lastly, let's delve into recommender systems. These are the algorithms working behind the scenes on platforms like Netflix, Amazon, and Spotify to curate personalized recommendations. By analyzing your behavior and preferences, these models can predict what movies you might enjoy, which products you're likely to purchase, or what songs you'll want to play next. They do this by identifying patterns in your past behavior and comparing them with the behavior of other users with similar tastes. So as you can see, machine learning is not some abstract concept confined to research labs. It's a vibrant technology that's already part of our everyday lives. Whether we're unlocking our phones, asking Siri for the weather, or simply picking a movie for movie night. From recognizing faces to recommending songs, machine learning is transforming the way we interact with technology. So there you have it, a basic guide to machine learning. We've journeyed together through the intriguing landscape of this powerful AI technique, shedding light on its three major types: supervised learning, unsupervised learning, and reinforcement learning. Each of these approaches has unique strengths and applications, from classifying spam emails, discovering hidden patterns in data, to mastering complex games like Go. We've also seen how machine learning is no longer confined to the realm of theory. It's already shaping our world in tangible ways, powering image recognition in autonomous vehicles, enabling human-like interaction through natural language processing, and personalizing our experiences on platforms like Netflix and Amazon. As we continue to generate more data and refine our algorithms, the potential of machine learning is bound to expand even further. So, keep your curiosity alive, because the future of AI promises to be a fascinating journey. Thanks for tuning in. Don't forget to like, subscribe, and leave a comment below. Together, let's continue to demystify AI and harness its potential for good. Until next time, keep exploring the world of AI.